We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope.
Because of the gravitational influences of everything else around. So we looked at a small group of objects newly discovered and realized we couldn't actually completely understand their motion.
Something massive just slammed into Neptune. Yes, you heard that right. Thanks to the James Webb Space Telescope, scientists spotted shocking signs of a giant collision. Infrared images, heat maps, and spectral data all point to one thing.
The moment we've been waiting for. You know, in outer space, there are so many planets and stars. We see them in all stages of their life cycle. Adolescence, middle age, even death. But we've never snagged that instant when a new planet is being born.
Something huge just rocked the distant ice giant like never before. Neptune. Neptune is the 8th and farthest planet from the Sun. It is often called the ice giant, and it truly lives up to the name. The planet is the 4th largest in our solar system. Its diameter is about 4 times bigger than Earth, and its mass is around 17 times greater. Despite being so massive, Neptune is still a mystery. Only one spacecraft has ever visited it. Voyager 2 flew by in 1989 and gave us the first close images. That flyby showed strange storms, thin rings, and swirling clouds. After that quick visit, Neptune has stayed hidden in the outer darkness of space. The atmosphere of Neptune is what makes it stand out. It is made mainly of hydrogen and helium with a little methane mixed in. Methane absorbs red light and reflects blue light, which gives the planet its striking deep blue color. Behind that beautiful appearance lies some of the wildest weather in the solar system. Winds race faster than 2,400 kilometers an hour, stronger than anything on Earth. Massive storms roll across the surface, and some are even larger than our entire planet. Neptune is huge, distant, and full of untold secrets. But this mysterious ice giant was about to become the center of the most shocking space event scientists have ever witnessed. The collision event analysis. The collision on Neptune is one of the most dramatic space events ever observed. Data from the James Webb Space Telescope revealed that the object striking the planet was incredibly large. Scientists estimate its size ranged from several dozen kilometers wide to possibly a few hundred kilometers across. An object of that scale most likely came from the distant Kuiper Belt, or perhaps from a wandering comet that drifted too close to Neptune's orbit. When it collided with the ice giant, the released energy was staggering. Experts compared it to millions of nuclear explosions happening at the same time. Such immense force helps explain the unusual heat and light patterns that Webb recorded in Neptune's upper atmosphere. Unlike Earth, Neptune has no solid surface. It is made almost entirely of gases and ices. As the incoming object pushed into the atmosphere, it began to break apart under overwhelming pressure. Eventually, it dissolved completely, scattering fragments throughout Neptune's skies. This violent entry added foreign materials into the planet's atmosphere. Researchers believe ammonia, carbon dioxide, and carbon-based molecules were among the compounds delivered. These new ingredients may spark chemical reactions that could alter Neptune's atmosphere in ways never seen before. The impact also generated shockwaves that tore through the planet's layers. These waves moved faster than the speed of sound and disturbed Neptune's already extreme weather patterns. Winds on Neptune are the fastest in the solar system, reaching nearly 2,400 kilometers per hour, and the shock of the collision may have created even more powerful storms. The energy ripples could continue to influence circulation in the atmosphere for many years. This event is more than a dramatic cosmic explosion. It shows how Neptune and the other outer planets serve as shields for the inner solar system. By pulling in or deflecting wandering bodies, they help protect Earth and its neighbors from destructive strikes. For scientists, the Neptune collision is a rare chance to watch a giant planet respond to a massive impact in real time. It opens the door to deeper knowledge about planetary chemistry, weather, and the continuing drama of our dynamic solar system. The impact itself was just the beginning. What scientists discovered next would change how we think about our entire solar system. Scientific implications and discoveries.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The collision on Neptune is more than just a dramatic space event. It also gives scientists new knowledge about how planets change and evolve. The impact shows that the solar system is still active. Collisions do not only happen near Earth or Mars, they also take place in the distant outer regions where giant planets like Neptune orbit. This means our solar system is still shaping itself, even billions of years after its birth. Neptune now becomes a natural laboratory, where scientists can study the effects of impacts on gas giants. The event also helps with comparative planetology. By learning how a massive strike changes Neptune, researchers can apply that knowledge to study gas giant exoplanets that orbit other stars. The aftermath of the impact will be studied for years. One area of focus is Neptune's atmosphere. The strike may have changed wind patterns that were already the fastest in the solar system. These winds, which can reach speeds of over 2,000 kilometers an hour, might shift direction or grow stronger because of the shock. The release of energy also disturbed Neptune's heat balance. This could alter how heat moves through the layers of gas, creating new circulation patterns across the planet. Chemical traces are another major clue. When the impactor dissolved, it left behind molecules like ammonia and carbon dioxide. These compounds may remain in Neptune's skies for decades. Scientists call these chemical scars because they act like fingerprints of the collision. By tracking these marks, researchers can follow how Neptune's atmosphere heals and changes over time. In the end, this single event connects planetary science, atmospheric studies, and even the search for life on distant exoplanets. Neptune's violent collision may rewrite what we know about giant worlds, yet these earth-shaking discoveries were only part of a much bigger story unfolding across space. Broader solar system context. To understand this collision, we also need to look at Neptune's place in the larger solar system. Neptune is not only a distant planet spinning quietly in the dark. It has an important role in shaping the movement of many small, icy worlds that live far beyond Pluto in a region called the Kuiper Belt. With its strong pull, Neptune changes the paths of these objects and sometimes even throws them deeper into space. In this way, Neptune works like a guardian. It protects the inner planets by attracting or deflecting wandering bodies that could cause damage if they traveled closer to the Sun. The impact that scientists just observed may be the result of Neptune's own influence. Over millions of years, its gravity might have pushed the object into a new path that eventually sent it crashing into the planet itself. The event may also have effects on Neptune's moons and rings. Triton, which is the largest moon, is already a strange world. Many researchers think Triton once lived in the Kuiper Belt before Neptune pulled it in. A collision of this size could slightly shift Triton's orbit or change the tidal pull between the Moon and Neptune. The planet's rings are another area of interest. They are thin and fragile compared to Saturn's bright rings. A strike like this one could have produced new dust and fragments that now add fresh material to Neptune's faint ring system. Even a small amount of new debris could change their brightness or shape. There may also be subtle effects deep inside the planet. A large strike can move energy and mass around, which leads to small changes in the gravitational field. These changes may affect how Neptune interacts with its moons and with nearby Kuiper Belt objects. When seen in this wider context, the collision shows how Neptune is still an active player in the solar system. It shapes orbits, protects the inner worlds, and sometimes even becomes the target of the very forces it sets in motion. But Neptune's role as our cosmic guardian isn't the only reason this collision matters. It's also teaching us about worlds we've never even visited. Exoplanet research applications. The collision on Neptune is not only important for learning about our own solar system, it also helps scientists study planets that orbit faraway stars. These are called exoplanets, and thousands have already been discovered. By watching how Neptune reacts to such a massive impact, researchers can build tools to better understand these distant worlds. One of the most valuable outcomes is the chance to create a spectral signature library. When the James Webb Space Telescope looked at Neptune, it recorded light patterns showing heat, gases, and chemicals released by the impact. These patterns can now serve as a reference for studying other planets. If astronomers see similar signals in an exoplanet's atmosphere, they can compare them to Neptune's event and figure out what might have happened there. Another major use comes from interpreting atmospheric changes. Impacts like this do not just produce light and heat for a short time. They leave behind long-lasting chemical scars and may even change wind systems or temperature flow. When scientists see strange or unexpected signals in the atmosphere of an exoplanet, they can now consider the possibility of an impact event. Neptune gives them a natural example of how a gas giant responds when struck by a huge object. This research also helps explain hot Neptune-type exoplanets. These are planets similar in size to Neptune, but orbiting much closer to their stars. Because of their location, they are often heated, stormy, and chemically active. By comparing them to Neptune after the collision, scientists can learn how violent events shape their evolution. They can also explore how impacts might influence long-term stability or even strip away parts of an atmosphere. In the end, Neptune's collision connects directly to exoplanet science. It turns a rare event in our own system into a guide for understanding countless other planets across the galaxy. While Neptune helps us understand distant planets, the collision is also forcing scientists to ask tough questions about our own safety. Future research directions. The Neptune collision has opened a new chapter for planetary science. To fully understand it, scientists will need years of long-term monitoring. Neptune's atmosphere shifts slowly, so the recovery process will be studied over decades. Researchers will track how the heat and shock energy fade and how the planet stabilizes after such a dramatic strike. Another key focus is storm evolution. Neptune already has the fastest winds in the solar system, and the collision may have disrupted their patterns. By observing cloud movements and storm spots over time, scientists can learn how new weather systems grow or disappear. The spread of chemicals is also important. The impact introduced compounds like ammonia and carbon-based molecules. Watching how these exotic materials disperse will reveal how Neptune's skies mix foreign elements and how long they remain detectable. This event also strengthens the case for a dedicated Neptune orbiter. Since Voyager 2's flyby in 1989, no spacecraft has returned for a close look. A future orbiter could provide constant measurements, track storm systems in detail, and study deeper atmospheric layers hidden from telescopes. Comparative studies would also benefit greatly. By comparing Neptune's response to impacts with Uranus and other giant planets, researchers can better understand planetary evolution in the outer solar system. This single collision has reminded scientists of Neptune's importance. With steady telescope monitoring and the hope of a future mission, Neptune will continue to reveal how giant planets react to cosmic impacts and how they shape the story of our solar system. As scientists plan decades of research ahead, they're also realizing this event carries a warning we can't ignore. Planetary defense and risk assessment. The huge strike on Neptune is not only a discovery about a faraway planet, it also helps us think about protecting Earth and the other inner worlds. Planets like Neptune and Jupiter act like shields in space. Their powerful gravity attracts or deflects many icy bodies and rocks that come from the Kuiper Belt or even farther out. Without this protection, Earth could face far more dangerous encounters. By learning from the Neptune impact, scientists can see how outer planets take many of the hits and help keep the inner solar system safer. The event also teaches us about how often such collisions take place. Impact frequency is one of the most important pieces of information for planetary defense. If Neptune can be struck by such a large body, then collisions may be more common than people once believed. Each new observation helps refine models of how often giant planets and even Earth are likely to face such threats. This knowledge can guide plans to track space rocks and prepare for possible impacts in the future. Gravitational dynamics are another lesson from this collision. Neptune's strong pull may have been the reason the object changed course and crashed into the planet. By studying this process, scientists can improve their ability to predict the paths of wandering bodies across the solar system. Better predictions mean more time to respond if any object starts heading toward Earth. In a larger sense, the impact on Neptune acts like a natural experiment in planetary defense. It shows how energy spreads when a giant planet takes a hit, and how that energy affects the surrounding system. With this new information, researchers can build stronger models, improve tracking systems, and sharpen their understanding of cosmic hazards. The story of Neptune's collision is also a reminder that impacts remain a part of the solar system's life. By studying them, humanity can prepare better for whatever the future may bring. Beyond the science and safety concerns, this cosmic collision touches something deeper about what it means to be human in an endless universe. Cultural and philosophical dimensions. The collision on Neptune is more than a scientific event. It is also something that stirs imagination and wonder. Long ago, people told stories about the gods of the sea, and the Romans gave the name Neptune to one of them. That god was seen as powerful and unpredictable, much like the deep ocean. Now we see a giant planet with the same name hit by a massive object, and the connection feels meaningful. The old myths and the new science both show how humans try to understand the forces around them. Watching such a powerful event gives us a fresh perspective. A single object, perhaps hundreds of kilometers wide, released energy equal to millions of nuclear explosions. That kind of force shows how small human concerns are compared to cosmic powers. It reminds us that our world is part of a much larger system that is always moving and changing. Events like this also inspire creative works. Just as ancient people painted or wrote about the skies, today's writers, artists, and musicians may find new ideas in the image of Neptune being struck by a giant visitor from space. From a wider view, the event highlights something essential about the universe. Collisions are not rare accidents. They are one of the main ways that planets and moons grow and evolve. They shape atmospheres, create storms, and even give birth to new moons. These changes happen over time spans so long that humans can barely imagine them. What happens in a single moment of impact may leave signs that last for millions of years. The Neptune strike also reminds us that the solar system is never still. It is a living environment that keeps changing. Every storm, every orbit, and every collision plays a part in shaping its story. For people on Earth, this view brings both humility and awe. We live in a universe that is active, unpredictable, and always inspiring. But perhaps the most amazing part isn't what happened to Neptune. It's how we were able to see it at all. Technical achievements. The Neptune collision also shows the technical power of the James Webb Space Telescope. This instrument was built to see in infrared light, and that skill made all the difference. Webb can notice very small changes in heat and energy, even from a planet as far away as Neptune. That level of precision allowed scientists to detect shock waves and chemical changes that would have been invisible to older telescopes. Another major achievement is Webb's ability to capture events in real time. Collisions of this size happen rarely and often pass quickly. The telescope was able to record images and data as the impact unfolded, preserving a moment that might have been lost forever. This proves Webb is not only good for studying distant galaxies, but also for following sudden events within our own solar system. The telescope also uses multispectral analysis. This means it can break down light into many layers to reveal the exact chemicals in an atmosphere. In Neptune's case, Webb identified compounds like ammonia, carbon dioxide, and carbon-based molecules that spread after the strike. These details help researchers understand how the collision reshaped the atmosphere. The data gathered is not simple images, but complex layers of information. Thermal mapping is one tool used to interpret the heat patterns left behind by the impact. Spectral decomposition allows scientists to separate light into pieces that reveal specific molecules. Comparative analysis then shows the difference between Neptune before the collision and after it. This step-by-step method is what turned raw telescope readings into a clear story of the event. These technical achievements highlight how far space science has come. With Webb's unmatched tools, researchers can study planets in ways that were impossible only a few decades ago. The Neptune collision has become not only a discovery about a distant world, but also a demonstration of the technology that is opening a new era of exploration. The Neptune collision is a reminder that our universe is alive with motion and surprise. Each discovery brings us closer to understanding the forces that shape worlds both near and far. If you enjoyed this breakdown, make sure to like, share, and subscribe. Stay tuned for more cosmic stories that reveal the wonders of space and science.